The point of this video is to explain the trend in electronegativity. Electronegativity is the ability to attract an electron. Okay? And if you think about what might attract those negative electrons, it would be the positive nucleus. Okay? So fluorine is the most electronegative element. This is a screenshot from a site called ptable.com. If you've never been, it's awesome. Okay? Each number below the element shows the electronegativity for that element, fluorine being the most electronegative. Okay? So as you move from left to right, okay, you can see in a given row that as you move from left to right, the electronegativity increases as you move toward fluorine. And as you move away from fluorine, as you move down, you can see the electronegativity value decreases, with francium being the least electronegative element. This is because this row on the left, this column, has one valence electron to give up. It wants to get rid of it. The ones on the far right have 7 valence electrons. They want to get that one more electron to get that 8, to get that octet rule. You can see most of the noble gases are all set. They do not want any more electrons, with the exception of krypton and xenon, who can do some cool stuff. Okay? All right, so why, as you move left to right, would the electronegativity value increase? Well, it's because you get more protons. If you think about the Bohr model of the atom, okay, the protons are in the middle and the electrons are on the outside. So if you're in shell 2, okay, you only have 2 shells. As you move left to right, you get more protons, okay, which sucks that electron cloud in. Okay, electrons and protons are attracted to each other. So as you move left to right, you get more protons, and you get a stronger pull on those negative electrons. So if you see another electron, if you're an atom and you see another electron floating by, it's very easy to suck it in if you have more protons, that stronger pull. Okay. And as you move from top to bottom, you're adding those shells. Okay, so the first row has 1 shell, n equals 1 in the Bohr model. The second row has 2 shells, n equals 2 in the Bohr model, 3 shells, 4 shells, 5 shells, 6 shells, all the way up to 7 shells in the Bohr model. So as you can see, the atom gets bigger and bigger as we add on more shells. And if there were an electron floating by out here, if there were 7 shells, it would be much harder to suck that electron into that very positive nucleus if there were more shells in the way. Whereas if there were only 1 shell in the way, like a hydrogen or a helium, that electron floating by would be much closer to that positive nucleus. Okay. This effect is called electron shielding, where literally these electron shells act as shields in the way of the nucleus. The more shields in the way, the harder it is for that electron to get towards the nucleus. Okay. So electronegativity is the ability to attract electrons. As we move toward fluorine, electronegativity increases. As we move away from fluorine towards francium, electronegativity decreases.